Hey YouTube, what's up? The other day we had the chance to interview retired NASA astronaut Cady Coleman, and man, that was a hoot. She's a great storyteller, and she's very relatable to anybody of any age regarding her stories and her experiences regarding outer space, the International Space Station, and so many other things. Enjoy this interview.
Have you talked to some of your fellow astronauts about the smell on the ISS and how it's changed since you were there?
I haven't heard that it's changed.
Okay.
There's a lot of kind of rumors about what it smells like. Okay. And I can only speak for, what was true on our mission. And I mean, we have like a certain amount of clothes, like 6 pairs of pants for 6 months and 6 shirts. Maybe sometimes it turns into 10 by the time people give you stuff, right? But then we have gym clothes, a lot of gym clothes. And I was the gym clothes police on our mission. I would say, okay, you guys, it's a special day. It's a special day. We are all wearing new gym clothes. And so that was that. But it didn't smell up there when we were up there. Although we have found that when there's a crew that has men and women, things tend to be a little tidier. I am not especially tidy myself, okay? You can ask anybody on my cruise. But there is a smell that people ask what space smells like.
Yeah.
And that is when a vehicle comes into dock. So here it is, it's coming in, and it's almost like 2 cups that come together, right? And so we're on the space station side, and they're on that side. And so this has been facing, in space, and it's empty. The cup is empty, so it's just space there, right? And it's made of metal, and it oxidizes. And so when then we go like this, and we make sure there's no air in there, and then we put our air into it so we can, have a full balloon of air, and that's when we open the hatches. So this is kind of like the front hall. So we open the hatches, but there's still this kind of lingering smell of it's kind of like metal. It's kind of like, you can sort of taste it.
Yeah.
It's kind of weird. And I think that's what people refer to as the smell of space, but that goes away pretty quickly. And it's only because one part of the airlock has been, outside.
You were in totality. You've been in space for 159 days. How did that work? Wow, that's one chunk.
Right, and so that was my almost 6-month mission, and then I had a 16-day flight to start with, a laboratory flight, and then a 5-day flight, really short, to launch the big telescope, because it was the biggest thing we ever brought, and there wasn't enough room for more fuel and food and all that kind of stuff, so only 5 people in the crew, and only 4 days.
So what's the process of deployment for the Chandra X-Ray Observatory?
So, so what happens, people think that we use the robotic arm to pick it up and put it out, and you could do that in theory, but there wasn't enough. It was so heavy already. It was the heaviest thing, 50,000 pounds that we ever brought. And the biggest, longest, it barely fit in the payload bay. And so the way that thing is deployed, the way it comes, it's a telescope plus a rocket on its butt. And the rocket is what's going to take it. If my fist is the Earth, it's going to take it not just around the Earth like us, but close. It's going to go 1/3 of the way to the moon, 80,000 kilometers, 80,000 miles, I forget which. So it's really far away. So it needs a rocket to get it into that orbit. So when so now we'll be the payload bay here, right? And you're the back of the payload bay, and you are the nose of the shuttle. Okay, you're one of the wings. And so this is the rocket on its butt. Here's the telescope, skinny end. We're gonna raise it up. It has a tilt table, so it raises up so that when I did the deploy, I push the button after everything checks out, and there's an explosive zip here, and there's springs, like as if you were just ready to push it. There's 5 springs that are around the back here, and so they just push it, and it's going to sail, because we tilted it up, it's going to sail over the head over the nose of the shuttle. Does that make sense?
Does it fire or?
No, it is purely mechanical springs, 5 of them. And then because we're NASA, we always think, what if this happens? What if this happens? And what if one of them doesn't push or is broken or crumped or something? And no matter what, even if it went a little crooked, we figure out all those, what is the worst thing that could happen? And what are we going to do about it? But with 5 springs, it's just enough to even push something that weighs 50,000 pounds. It might have been 40, I forget. But those springs are enough. And that's because up in space without gravity, when we're inside the cabin, if you could take, even your hair, okay, and yours too, could take one hair from your head, put it between your fingers, and if you then pushed, if I pushed against your arm here, I would push myself across the whole space station or the shuttle. And so that's why just those springs are enough to push that big. It's not going to go fast with that big spacecraft out there because, up in space, it just takes that little force to move. So just a little touch of your pinky. And so we fly everywhere up there. We don't walk, and we don't really kind of grab, because you just give yourself a little push, and then there you go. It's the best thing about it.
And then does the satellite just turn on as soon as it's in space, or how does it work?
So that's controlled by the ground, and we're from the shuttle. We're actually enabling to make sure the antennas are powered and things like that. And so the ground is actually, that's some of the checks we do. We make sure that they can talk to the spacecraft, and then it's their baby. And you have to remember, like, this telescope was dreamed of and created by these scientists 25 years earlier. So this is their dream, but then it's going to be operated by engineers, and it turns out like a big whole telescope family. And so 25 years ago, we deployed the Chandra X-Ray Observatory on this mission, on this patch.
Wow.
With Eileen
Collins, first woman commander. It was only supposed to work for 5 years, and it's still working, actually, amazingly. There are some things that don't work as well, but it's still, literally every single sentence in a scientific journal that involves black hole comes from this telescope.
How long does it take to get to space?
Pretty much, it depends how far you're going, right? But in general, we as people are, if my fist is the Earth, we're about like 250 miles up, maybe 300 or 400.
And where's the moon in that equation?
Way out the door. Yeah, really far. And so, it's because the moon is 240,000 miles away, or so.
So the telescope would have been 80,000 miles up.
Yes, and so it's towards the moon. So it goes a third of the way to the moon, comes back, and it's about, 20,000 kilometers on this side. I forget. I'm not the best one for remembering all the numbers, but kind of remembering how things work and stuff. But, your question was how long does it take to get to space? And it's a really good one because really our whole goal, what we have to do is get going fast enough that we can escape the gravity of the Earth, but just enough to then keep going around. And that takes about 8.5 minutes.
Every launch that you launch a spacecraft, there's like these tables that stabilize the rocket. Mm-hmm. Do those damage anything, or does it just go on the side into the ground?
You mean the things that are holding the rocket up?
Yeah.
Pretty much those just stay, and they are built to endure that. And that's actually something that we saw when the Starliner, the really big rocket that Elon Musk is building, is because his is so big, they calculated what, is the flame pit that we're building, is that going to be enough? And it turned out the answer was no. Okay, they had a lot of concrete and stuff like that, and I am not making fun here. What is really interesting about doing things with these new companies is that they can afford, because it's their money, they can afford to say, what if we didn't just make sure that it happened perfectly the very first time? And it's questions like, how much of a heat shield do you need when you come back in to protect the bottom of the space of the shuttle or of the capsule? And we know what we used in the Apollo program, but did we need to use that much? Pretty much we always go, okay, if we need one of these, then we better bring 3 in case, if we need a heat shield this big, we better build it this big. So there always are a margin of safety, we call it. But there's a lot of assumptions that are built in there, and we've learned a lot of things. And so the very first mission to the moon that we did a couple of years ago as part of the Artemis program, where we're going to go back to the moon, no people on board. They actually said, what if we could get away with a skinnier heat shield? And it makes such a difference because, we're thinking about we're going to be in a capsule, we want exercise machines, and, we want to be able to exercise, and we want more food, we want more margin in food and water. But if we have to give all that weight to the heat shield, so companies like SpaceX can say, let's figure out if we've been thinking about this too conservatively all along. And it turns out it was that didn't work. And then they fix it. But that means that all of us, not just SpaceX, all of us learned lessons. Does that make sense?
Yeah.
So the stabilizers don't break?
The stabilizers?
Yeah.
On the rocket?
That hold up
the rocket?
Rocket, yeah.
Yeah, on the launch pad? I don't think theirs broke either. It was more that there was so much fire. There's a level that's on one level, but then the fire of the rocket goes down into the flame pit, and that actually got so hot that it exploded the concrete. And so they thought about, should we cool that with like a big river running under it, right? And the answer is, or with steel, concrete. I can't remember exactly how they did it, but whatever they decided, it wasn't enough. But you're thinking about. So here's, and it's a good question. Here's the plate that the rocket is sitting on, attached, and does that get damaged? Pretty much no, if launches happen the way they planned. And for the shuttle, those big white looks like rockets, candles, on the side there. They're each held down by 4 bolts on each side.
4 bolts.
4 bolts. And these bolts are about, the nuts are about this big, and the bolts are like this big, and they have explosive charges in them that explode at liftoff. And when we get home, we each get one of the exploded bolts.
Cool.
My husband thought we should name our band the explosive bolts, right? But they're really cool because they have dynamite, or they have a charge inside, and at 3, 2, 1 liftoff. That's what they do, and that's part of why it doesn't damage the launch pad. I think it's a smart question.
So it's like a button that the control area presses to make it explode.
Well, it depends on the rocket design, and I don't know what kind of rockets the two of you might design, because we've thought about it certain ways for a long time.
Mm-hmm.
But computers have changed, the speed, the confidence you have that a command could go out. I mean, how on a computer you used to, you kind of like double click, and then you kind of have to wait. And but now it's like,
no idea.
Now it's faster, right? But there are things that you get frustrated about your games and things like that, right? About that they don't run right, or when you're in somebody else's house and they're not, you're like, oh, the bandwidth or whatever. Those problems are things that just get those challenges. People meet those challenges, and circumstances change. So somebody has to look back.
What's the thing about space that the public who may not appreciate space, or say, let's not put any more money towards space exploration, that you could say to them that would otherwise change their mind?
Get some copies of Spin-Off.
Oh, it is. I love
What is that?
Well, so every year NASA puts out like a book, something like a picture book, and it's about what are the things that the technology that we have created because we think we might need it, and how is it used now? And it's everything. Some of my favorite examples are that the cooling in our spacesuits. That principle is applied to race car drivers, and how they are and keeping them safer. But then it also applies to people. There are kids that can't be in a regular environment and have to always be cooled. So there's always all these applications. I like the experiments that we do up there, which are not necessarily in spin-offs, but literally all the things that we do up there. I'm a scientist originally, but we take away gravity. It's a big thing to take away because everything, you see us flying around, everything is different. And so if we're going to grow corn in space, I'm from in Massachusetts, and it's time for corn in August, right? And corn stalks are like this tall.
They're huge.
Because they have to be strong to hold up the corn. But in zero gravity, we are not going to need a strong corn stalk. So we would want in Mars, we'll need a little bit of a corn stalk, right? And on the moon. And so we can learn how to, how to grow things. And the things that we learn for space, like how to grow things in places where it's really hard to do that, those lessons, there's places here on Earth where we don't have good enough soil or light or water. And so how do we grow things in places so we can grow more food for people here on Earth? So those lessons apply. We look at, combustion and how you see a candle flame. Gravity is working like really hard. Every time you see a birthday cake, that flame, the pointy thing. So the hot gases that are given off are like going up like a hot air balloon. And then new fuel is rushing in. It's like a wildly, a lot of things going on, hard to understand. In space, those lighter gases, light, heavy, doesn't matter. They stay right there. Our candle flames are round. They burn really slowly. Measurements that, I don't know, do you ever do graphing in school where you make points on a graph? What we have to measure and decide the slope of a line in like a couple hundredths of a second, those measurements, when we're making those measurements, because it happens so fast. And down here, up in space, what happens in just a few, fraction of a second, half second, happens over 30 or 40 seconds. So deciding on that slope of the line, you're like, Is that it? Is this it? I mean, what's the error? What is it really? And it means a lot about combustion. But if you could go ding, 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 you'd have a lot more confidence in that answer. So because things act differently, we learn about them. I mean, we want to understand how things burn in space. We want to be able to know how to put out a fire in space, right? Yeah. But it means a lot down here, too.
Yeah. So you mentioned laundry, or did you?
I did not. I did not. Well, and we could, we do you think I'm giving you the answer, but how do you think we could do laundry up there? Any ideas? It's not like a trick question. I mean, we could just take like a baggie, like is it?
I've got like
baggie?
a shake and bake answer.
Exactly.
Like that?
We could do that. We could have a washing machine up there. I mean, if we can have all the technology we have, we can have a washing machine on the space station. But it takes up space. Probably have to like wipe it out and make it dry every time. And even at home, we don't always do all the maintenance we should on our washing machine or our dryer. And then you pull the little filter out. You're like,
the lid
right?
filter.
And so we can't really have that and have mold and stuff like that. So it would be a lot of time and cleaning to have a washing machine. And right now, and so the way we've focused is how can we design clothes, sometimes with silver thread inside them, that you can wear for longer and they don't get smelly. And so, and right now we just bring up, you really don't need, like when you go camping or on a trip, you really don't wear all your clothes usually, right?
No, you don't.
Unless you brought a few outfits to Dragon Con, and then you probably wear all of them.
Kids, what would you say to kids who are intimidated by the science and the math in schools today?
I would say this
because they love space.
Well, it's a language, and it's I think making sure that you can do some math. And here's, I think, like, you might think astronauts are good at, like, everything. We're certainly not. But especially at maybe everything science or everything math. I have a certain intuition for chemistry. Physics is actually really difficult for me. And so I find that when someone says, oh, it works like this, I actually have to ask them another way. Can you explain that to me another way? And sometimes I'm asking 5 different people for explanations because I have to find one that works for my brain. And so I encourage people to learn about math, mostly because you need to be able to listen to the news. And when somebody says, you should do this, you should get vaccinated, you should be careful about this, everyone should do that with their children, you need to understand what they're saying. Because if they say, a certain percentage, I don't know, like if you read one news story about some restaurant having bad food or something like that, and you go, wow, there's bad food in every restaurant. Unless you actually, you read the facts there and realize, first of all, that it was just one place, and second, that there was an explanation that everybody learned from. So I think you want to be able to understand where you live and how to be safe, how to keep your family safe. Yep.
If there are floating parts in space...
What do you mean floating parts?
Like, if there's parts of a rocket, or if part of...
You mean like space junk?
Like,
space junk?
Yeah. What are the effects of it?
Well, it's huge, and it's a really good question, especially because we're launching a lot more things. So here's my fist, right? And we're going around in orbit. We're going 17,500 miles an hour. Well, what if somebody else made a rocket and didn't and ended up something happened and it blew up, and maybe they're going the other direction. I mean, we could have a head-on collision, and even if you had a head-on collision, even at 17,500 miles an hour or 1,000 miles an hour, I mean, that's a pretty big head-on collision. And the good news is that we understand where a lot of that is. We actually keep track of everything that's bigger than about 2 inches up there. But the bad news is, and that was about 20. I think a couple of years ago we knew there was about 26,000 pieces of junk that were bigger than this. And the bad news is that we have actually figured out that now that we can measure more easily, now that we have better ways to look at how much is up there, that measuring things that are only about this big, about a centimeter big, it's more like 200,000.
Wow.
How can you see how much space junk is up there?
They have radars. And they're building radars all over the world so that they can measure this and understand this, because we can actually move the space station if we need to, or other spacecraft and we do, right? We can also, if there's no time to move, because it's pretty big and it moves slowly, then we can climb in our rescue ships so that we're at least ready to go if we have to, if we get. But also, I mean, it's like your bike tire. I mean, we can fix leaks too. It depends on the leak, and we have a very organized system. Like, here's the space station. First thing we do when we know there's a leak is we measure how fast it's leaking. We are looking at measurement gauges, manometers, right? And then we shut the hatch in the middle. We get everybody on the side of their rescue ships. Everybody has to be. We never shut the door and have your rescue ship, the one you're going to go home in, on the other side. So we figure out which half of the space station is it in. Oh, it's in this half. And then we shut other hatches and other hatches. And it's very logical as long as you kind of keep your head and just follow the procedure that you've been taught and keep your teammates and yourself, just really following the directions really well. It's kind of like in here, I actually think about here in Dragon Con, there's a lot of people, and what would happen if we were all afraid at the same time? And I think that actually everybody in this crowd does enough gaming and science fiction and what if. I think in their heads they already have kind of thought through this kind of thing and realized, like, when this happens, we are now in some little future scenario that we've either written or read about or watched, and we are going to calmly go to the places we want to go. There'll be enough Dragon Conners that think that, I think, because I think Dragon Conners live in these alternative universes. I mean, in that they have the imagination to go there.
They're puzzlers.
And it's really great for all of us, really.
How high do you have to be before you can clearly see the curvature of the Earth?
I think that people who are going 50 miles are definitely seeing the curvature of the Earth. And, this thing about, can I tell you a couple of things that I think are important to know, like, right now? Yeah. Which is, when you hear about Virgin Galactic and you hear about Blue Origin, and they're actually, remember we talked about going up with
like
enough
25
of a rocket,
miles.
Right.
Yeah.
And they're 50 miles.
Okay.
And one of them's 50 miles and one of them's like 60. I mean, it doesn't matter. I mean, they're going to be weightless for a few minutes, and they're going to see the curve of the Earth. And they're actually going to see the Earth, and it's going to give you this perspective that, you never really had. And even now with our better cameras, you have those perspectives. So I have great respect for those programs. The media likes to talk about the 3 billionaires, and they like to talk about their personalities. But these are 3 people and who have families, actually, and who really have a vision and resources, and each has a different vision of how to get people to space. So don't be sort of distracted by the noise, and really listen to the news. And that's especially true lately, where Suni and Butch are up there, and there's been a number of people that have asked me, hey, how come aren't there more people in space? Why do they only talk about those 2 people? Well, good question. Okay, and Suni and Butch are on a test mission. They signed up. They were assigned as the shepherds for that capsule. The astronauts that would say, "Hey, that's not going to work for us," right? And I think it's important to know this, because not many people your age and not many people out in the world are understanding this. Is that so? They babysat that for years. They got to go. It was only going to be an 8-day mission, just because that was like they'd get it back here. They'd make another mission, but with different astronauts. But then when it got there, the thrusters didn't really work right, and they needed to understand why they didn't work right. So they got to stay longer, and then it turns out that the safest way, because now they understand what happened with the thrusters, but they don't understand how to control it so that they can make sure they come home safely. So the safest way is for them to come home on different ships, right? But here, think about Suni and Butch assigned several years ago, shepherding, working really hard, waiting for their turn, and now, instead of 8 days, they get to be up in space for months. They're both trained astronauts. You look at their faces on the video, you are seeing exactly how they feel. I mean, this word, do not use the S word, okay? The stranded word. I will be disappointed if I hear you use the stranded word, except to explain this. And I work with the media some, and I've said, to the person who I, give my viewpoint to, for one of the news networks. I mean, why do I keep hearing the S word, stranded, when this is NASA at its best, working and figuring out what's next and what's the right thing to do? And they said, we tell all of the people above us that they are not stranded. It's NASA making good and judicious choices, right? And that Suni and Butch are just fine, if not so happy. And so the media, but stranded gets people to watch the news. Yeah. If we have even one incident here at Dragon Con, that's going to be the thing you hear about on the news, right? One person hurt, or whatever. When, and it's like Boeing. We hear lots of bad things about Boeing. Boeing built a space station. I mean, they sent all the supplies up. I mean, they're just amazing. They've done a gazillion things right, and people want to focus on the one thing. So listen to the news, and that's why that math thing comes in. Think about that gazillion things Boeing has done right, and the very few that we're looking at, how could we have done better?